June 2019, paper 6, variant 1. The diagram shows the apparatus a student used to prepare a dry sample of chlorine gas. Chlorine is more dense than air. It's very important to read the rubric of the question because he gave us a very important piece of information that chlorine is more dense than air. Also, any halogen you're dealing with is dangerous or toxic. You can't inhale it. Okay, so as a safety precaution, you should do the experiment in a fume cupboard. Like after that, he's asking you to complete the boxes of the apparatus below. This is a conic flask, and this is a gas jar. You cannot say measuring cylinder. Okay, this is not a measuring cylinder. How can you know the difference between a measuring cylinder and a gas jar? A measuring cylinder should be calibrated. Calibrated, and it has these measuring units here. Okay, so the measuring cylinder is calibrated. The gas jar is uncalibrated. It's exactly like the measuring cylinder, but it's uncalibrated. Number B, use the diagram to identify two mistakes the student made. Number 1, he doesn't put a stopper or a bung in the second conical flask. Okay, so any gas coming out from this flask will escape if he didn't add the bung or the stopper. Number 2, since that chlorine is more dense than air, it shouldn't be collected by an inverted gas jar. This is an inverted gas jar. Chlorine is more dense than air, which means that as soon as it gets out of this tube, it will escape as it will go down because it's more dense than air. He should have collected chlorine with a normal gas jar, not an inverted gas jar, okay? We call this way of collection upward delivery. We call this way of collection upward delivery. We call this way of collecting a gas downward delivery. So if the gas jar is looking upward, it's upward delivery. It's looking down, it's downward delivery. So the gas jar shouldn't be inverted, or the gas, you can say the gas should not be collected by upward delivery. Okay. Suggest one reason why the gas produced in flask 1 is passed through concentrated sulfuric acid. Take care. Concentrated sulfuric acid's main use in our syllabus is as a drying agent. Okay, a drying agent. It absorbs water from anything. So the reason the gas is passed through this acid is to remove water or to dry it. You can say to remove water or to dry it, okay? Okay. D, describe a test for chlorine. You can say blue litmus paper or litmus paper. It bleaches or it turns white. Actually, I need you to know that it turns red then white or it turns red then bleaches in case he asked for 2 colors. So blue litmus paper, it turns white or it bleaches. Suggest why the experiment is done in a fume cupboard because chlorine is toxic or poisonous. The only reason you do anything in a fume cupboard is because you don't want to inhale the gases produced. This is a very important question, okay? Also, I want to say something here. This is not a burette. This is not a burette. This is called a tap funnel. Please write this. This is called a tap funnel, not a burette. This is the tap. This is the only significant thing in the whole apparatus. How would I know if this was a burette? From the calibration. So take care. A calibrated apparatus is different than an uncalibrated apparatus. The calibrated, if this was calibrated, it would have been burette. If this was calibrated, it would have been measuring cylinder. Okay, but because it's uncalibrated, this one, okay, we call it a tap funnel because it only has a tap. And you use it when you don't need to add a certain volume. You just need to add the acid to the flask. Okay, experiment 2, please read the question carefully. It's a reaction between sodium carbonate and barium nitrate, which produces an insoluble solid that's barium carbonate. Okay, and every time he's measuring the height of the solid formed in each test tube, each time he's just adding more and more sodium carbonate to the flask. To the tube, okay? Is just increasing the volume of sodium carbonate. Okay, the volume of aqueous sodium carbonate, 1, 2, 4, 5, 6, 7, 8. You get them from here. Then at the bottom, the height of the solid, take care per millimeter. If you do it in centimeter, everything will crumble because even the graph will not be accurate. 12, 24, 48, 60, 73, 73, 73. Okay? You should have measured it with a ruler accurately, because there is no percentage error in these readings. If you didn't get exactly these readings, you will not take the marks. Okay. Now you plot the results and you draw two intersecting lines of best fit. If he said straight lines or lines of best fit, this means you use a ruler, okay? And he wants you to label the x-axis. This is very important to read also the rubric carefully. Label the x-axis. The x-axis is the volume of aqueous sodium carbonate per centimeter cubed. Then you plot your results. You draw two intersecting lines. This is one and this is the other, okay? You don't have to add these extensions. If you do them exactly to the point, no problem. This is the graph, please correct it. The labeling of the axis is for 1 mark, the intersection here is for 1 mark, and the two lines each is for 1 mark. From your graph, deduce the height of the solid formed when 3 centimeters of sodium carbonate are added to 6 of barium nitrate. Okay, since the x-axis is about sodium carbonate, so you will come at 3 centimeter cube. You will do two perpendicular lines until you read the y-axis. It will be around 36 millimeters. Describe the trend in the heights. D. Describe the trend in the heights of the solids formed in test tubes 1 to 7. What does he mean by the trend? He means as the volume of thiosulfate increases, as the volume increases, what's happening to the height? Okay, as the volume increases of thiosulfate, the height increases till it becomes constant or it levels off. Most of the students don't get the last mark. You forget to say that at the end it becomes constant or it levels off. Okay, so as the volume of thiosulfate increases, doesn't take any mark. The height increases, this is the mark most of you get, till it becomes constant or it levels off is the final mark. Okay, predict what would happen to the if the experiment was continued using 3 further test tubes, each containing 6 centimeter cube of barium nitrate and separately adding 9, 10, and 11 centimeter cube of aqueous sodium carbonate to each one. This is very important, please. He's asking what will happen if you added 9, 10, and 11 centimeter cube of sodium carbonate. Take care, the reaction has already finished at 6 centimeter cube of sodium carbonate. So if you kept adding sodium carbonate, the volume, the height of the solid will remain the same. Why? Because the maximum amount of barium nitrate or whatever he added was 6 centimeter cube, and he tells you here he tells you here that he will keep adding only 6 centimeter cube of barium nitrate, and he will increase the volume of sodium thiosulfate. The barium nitrate already, the 6 centimeter cube, the maximum they can produce in height is the 73 millimeter of height. So if you increase the sodium carbonate, nothing will happen, okay? Nothing will happen. Same height, okay? Same height will be reached, takes 1 mark, because all barium nitrate has reacted. You can't tell me because the reaction has finished, okay? This is not an accurate answer. You need to tell me because all the barium carbonate has reacted. That's why nothing more will happen. These are the 2 marks. F, suggest one change to the apparatus which should be made to obtain more accurate results. The first thing you do when you read this question is to search for the usage of measuring cylinder. If you found it, it's your lucky day. You will say use a burette or pipette. Okay. Suggests a different method to measure the amount of the solid formed during the experiment. This is a good question. He used the height here to measure the amount of the solid. Another way is to measure the mass of the solid. We can compare between these experiments by measuring the mass of the solid. In order to get the mass of the solid, you will need to filter to get the mass, and whenever we filter an insoluble solid, we dry it, okay? So you will filter, you will dry, and you will weigh the solid. That's why the 3 marks, okay? Filter, dry, and weigh. Take care, paper 6 needs details, needs steps. That's why he gave you 3 marks for a question that if he got in paper 4, he probably would have gotten 1 mark just for saying weigh the solid. Suggest how the reliability of the results could be checked. Please focus with me on this question. There are 2 types of questions in paper 6 that may come. Suggest how, okay, let's write it here. Suggest how. And then he can ask about 2 things. Suggest how the results could be improved, or suggest how the reliability okay, the reliability of results could be checked. Two types of questions. Okay, what's the difference? The results could be improved means how can we get more accurate results, okay? How can we decrease the percentage error in our results? To do that, you repeat the experiment and take average of the results, okay? If you want to minimize the percentage error, you do the experiment several times and you take average for all of your results. That's how you can improve the results and make sure they are more accurate, okay? But the reliability of the results means how can I know that when I did this experiment, everything was perfect, everything was accurate. I do the experiment again, okay, and I check that the results are reliable by comparing them to the experiment I've done. Okay, so if you did the experiment on Sunday and you used the chemicals in the lab and you came again on Monday and did it in a different lab with different chemicals and you've got the same results, that means that the results are reliable. They can be trusted because doing them again under the same or different even conditions using the same chemicals with the same concentration gave the same results. So take care. When you check for the reliability, you must say repeat and compare the results. I know no IG students are programmed to say repeat and take average, but this time you must say repeat and compare if he said reliability. Okay? Cations and anions, two substances, F and solid G, solution F and solid G were analyzed. Solution F was dilute hydrochloric acid. Tests were done on solution F and solid G. The solid was divided into 4 test tubes and he's asking for the pH. Since it was dilute hydrochloric acid, which is a strong acid, you'll say any pH from 0 to 3. Okay. Magnesium ribbon was added to the second portion of solution F. Magnesium added to HCl. Definitely it will produce magnesium chloride plus hydrogen gas. So you will say bubbles or fizz or effervescence. And then he said the gas was tested, so lighted splint pop sound. Okay, 3 marks. Bubbles or fizz or effervescence, lighted splint pop sound. C, dilute nitric acid and aqueous silver nitrate were added. Silver nitrate is the test for halides. We have hydrochloric acid, which means chloride ion is present, so white precipitate. D, dilute nitric acid and aqueous barium nitrate are added. Barium nitrate is the test for sulfate. Okay, we don't have sulfate, we have chloride, so no change. Tests on solid G, okay? The appearance of the solid was studied. White solid, please. Whenever you read that a solid salt is white, you must think this must be a metal from group 1, 2, or 3, or zinc. These are the elements in the periodic table that form white compounds, okay? Then he's saying that dilute hydrochloric acid was added to G. The gas produced were tested. Rapid effervescence, lime water turns milky. Whenever you read lime water turns milky, you know that carbon dioxide gas is produced and you know that carbonate ion is present, okay? 2 pieces of information على طول when you read lime water turned milky. Test 2, an excess of barium of aqueous sodium hydroxide was added. Take care, he added excess from the beginning. White PPT, okay? White PPT insoluble in excess. With ammonia, no PPT. There's only one cation that produces no PPT with ammonia, which is calcium. So we know here that there is carbonate. We know here that there is calcium. The solid is calcium carbonate. Okay, the final experimental design. This was a very tricky one. Steel nails rust in the presence of air and water. First, you need to know how do we measure rust? How to know that something rusted more than the other? How to measure rust? The answer is one word. We measure the increase in mass, okay? Take care, rusting means that iron changes into hydrated iron oxide, iron 3 oxide. So the mass of the rust is, the rust causes an increase in mass. When you want to measure the rate of rusting, you measure the increase in mass. Steel nails rust in the presence of air and water. Plan an investigation too. Take care, you must cover all of these bullet points in your answer. To show that coating steel nails with paint helps protect the nail from rusting, and show that coating steel nails with zinc help protect the nails from rusting. So you will need to do an experiment where you add normal nails to water in order to show that they rust, and you will add, okay, nails that are coated with zinc and nails that are coated with paint to show that when they are coated, they rust with a lower percentage or they rust less. Determine which coating is more effective at protecting the steel nails from rusting, okay? So take care, there are 2 things we need to know. That coating them in the first place protects the nails from rusting, and that covering the steel nail with paint and zinc protects them from rusting, but we need to know which is better, coating it with paint or coating it with zinc. He gave you uncoated steel nails. Please read carefully what he gave you, so you will need to do something with the uncoated steel nails. Steel nails coated with paint, steel nails coated with zinc, and common laboratory apparatus. The answer is you will get 2 nails, or you can say more, of equal weight or pre-weight. You need to know the weight of the nails you're starting with. You will place them in a test tube or any suitable container. You can say beaker, conical flask, whatever. Add water to both nails. Leave in water for at least 1 week. Take care. You can never say you're measuring the rusting in 1 day or in 3 hours or anything like that. Rusting is measured in at least a week. Nothing happens in less than a week. This is very important. You need to be realistic in your time interval. Number 5, dry. Whenever you add anything in water and you're weighing it, you weigh it as dry, because the water may weigh with you an excess weight that you don't need. Dry and reweigh the nails, okay? So now you've measured the amount of rust in the uncoated nails. You'll say repeat with nails covered with paint and zinc. كده you've proven already that that covering it with paint or zinc will be better than uncoated nails. You would say the conclusion بقى, the nail with the lowest increase in mass had the best coating. The nail with the lowest increase in mass from these nails covered with paint and zinc has the best coating. Okay, this was June 2019 by Mr. Marco Medhat.